Hello everybody, this is Miss Pikarski. Today is the first day of spring, and so I decided to have a nice springy background. I hope you like it. We are going to go over the trig identities test review in this video. Please watch it, even if you are in class for the review. It'll help you to go over this. All right, so before we get started, I wanted to remind you about how to verify or prove an identity algebraically. There are some steps that just make it a little bit easier to accomplish. And let me do this. Okay, so the first step is you want to start with the more complicated expression in the equation, and then you work to simplify it. It's most of the time you're going to want to put everything in terms of sine and cosine. This one is a huge deal. It will save your butt and make things a lot easier. Then you're going to do your basic math to basically transform the expression by making substitutions, simplifying fractions, combining like terms, and algebraically manipulating the variables. Basically, you're going to add, subtract, multiply, and divide so that you can simplify everything. And then another key thing that will help you is to remember to use the Pythagorean identities. If you have any squared terms or any ones, it's an indicator that a Pythagorean identity will help. Your reciprocal identities, if you have secant or cosecant, you can use your reciprocal identities to get rid of those, and then quotient identities to get rid of tangent or cotangent. Okay. A couple other things. This that we just went over is in your purple notes. This is also in your purple notes. I'm not sure exactly where. Just some more solving tips on how to use identities to replace unwanted expressions. And there are some examples in here. So use all the preceding tips that we just went over. And then in many cases, the equation can be simplified and solved by using identities to rewrite expressions in terms of sine or cosine. We've already covered that. But specifically for like your half angle and your double angle identities, if you had tangent x over 2, you can use your half angle identity and get rid of the tangent, and you'd have 1 minus cosine x divided by sine x. And then in other circumstances, it may be wiser to replace a complicated expression involving sines and cosine with a simpler expression involving only one function. For example, it may be beneficial to replace something like this craziness with tangent x divided by 2. We're not going to see this a whole lot. Mostly it's going to be this one up here, where we're going from the tangent x divided by 2 to this here. If you get stuck, go back and look over all the identities for something that looks familiar. Remember all your Pythagorean identities and the variations to it and everything else like that. Those will typically help you. All right, so let's look at our first example. Remember for the test that you are going to be able to use your trig table with all your trig identities in it. Let me make this a little bit smaller and move it down a little bit so you can see it. There we go. So this is just your reciprocal identities, Pythagorean identities, your quotient identities. I'll refer back to these a couple times. So let's say we have a problem like this. So you have sine x times tangent x plus cosine x, and we have to simplify this to get secant x here. Okay. And there's several different steps in the process, and you need to show your work through the whole thing. Okay. So if you're starting with this, first thing you want to do is put everything in terms of sine and cosine. Okay, well, sine x is already in terms of sine and cosine, so you're not doing anything with that. Tangent x, you can change it to sine over cosine. That's your quotient identity. And then plus cosine x will just stay cosine x there. Okay, now you have all this. You want to, you have sine x times sine x divided by cosine x. This part here simplifies to sine squared x in the numerator and then just cosine x in the denominator. okay? And then, so that's like this whole thing right here, simplifies to that. Now cosine x will just be cosine x. However, you have a fraction here, and you want to add this to it. In order to add with fractions, you have to have a common denominator. So you're going to multiply cosine x by cosine divided by cosine, okay? When you do that, you can then add your fractions together. So in the numerator, you have sine squared x plus cosine squared x. The cosine x times cosine x becomes cosine squared x. And then in the denominator, we're just left with cosine x, okay? Now, to simplify the numerator, you have two squared terms. You have sine squared x plus cosine squared x, and according to the Pythagorean identity, that equals 1. So numerator, this whole crazy mess right here, just simplified to a 1. And then cosine x, or your denominator, is still just cosine x. It hasn't changed, okay? But this is the reciprocal of secant x. So, or since cosine x is the reciprocal of secant x, then this equals secant x. So that's how we were able to solve this. On your test, you're going to have problems very similar to what we just had. You'll have your starting point, you'll have what your final answer was, and then you'll have some of the stuff here, like you might have the division line here, you might have the plus sign here and here, and you have to figure out, okay, what are the steps to go from here to here, and you have to show all your work for it, okay? Now here's another one. You have sine x divided by 2 times cosine of x divided by 2. Okay, so hopefully you can recognize that these are your half angle. You're going to be using your half angle identities to expand that. And notice that your final answer down here is just sine x divided by 2. Okay, and like I just said earlier, is you'll have some of the format. So like on your test, you'll have like all these radicals everywhere, and you have to figure out what goes under the radicals. So for sine x divided by 2, you're going to want to pull up your half angle identities. Let me see where they are. Yeah, here's the half angle identities. So let me move it this way. There we go. So sine of x divided by 2, you can replace it with all this, okay? And so we are just going to have the square root of 1 minus cosine x divided by 2. And then cosine x over 2, that's another half angle identity. And that's the formula that you would replace the cosine x with. Okay. Now, I hope that you guys remember that when you're adding radicals, you cannot combine them. But when you're multiplying radicals, you can combine everything. And so because we're multiplying here, we can combine those two. And so in the numerator, you have 1 minus cosine x times 1 plus cosine x. And then in the denominator, you multiply straight across for the numerator and the denominator. You just end up with a 4 there, okay? Now, at this point, you need to go ahead and FOIL your numerator. And because you have a minus cosine x here and a plus cosine x here, your middle terms end up canceling out. So you get a 1. 1 times 1 is 1. 1 times cosine x is cosine x. Negative cosine x times 1 is negative or minus cosine x. So those two terms cancel out. And then negative cosine x times cosine x is just a negative cosine squared x. Okay, and then in the denominator, we're still just stuck with the 4. That's not going to change yet. Okay, now you need to figure out, okay, what can I substitute in 1 minus cosine squared x? Remember, if I said if there's a squared term, that's an indicator you're going to use your Pythagorean identities. Okay, so let's go up. Here's our Pythagorean identities, and we are looking for 1 minus cosine squared x. That's not what I wanted. Dang it. All right, I might have my calculator popping up. I'll have to close it later. So let's say we wanted 1 minus cosine squared x is right here, 1 minus cosine squared x, and that equals sine squared x. So that means I can replace this whole craziness in my numerator with just sine squared x. Okay, and then in my denominator, I still have a 4 down here. All right, and then the final step is, because these are both squared terms, I can square root them. All right, so I know this was a little bit confusing. Biggest thing, remember, if you have x divided by 2, use your half angle identities. And just when you're multiplying your fractions, remember you multiply the numerators together and you multiply the denominators together. All right, couple other reminders before we see another problem is just, what are the reciprocals of cosecant? Cosecant is 1 over sine x, and then the reciprocal of secant would be, or the equivalent of secant is 1 over cosine x, because those are reciprocals of each other. And also remember, notice we had an x here, so we have an x here. We had an x here, and so we have an x here. But it doesn't matter what you have in the parentheses. If you had some craziness like x plus pi, it would be 1 over sine x plus pi. So the stuff that's in parentheses will just stick with your trig identity or your trig function, okay? So same thing with secant, you could have 1 over cosine x plus pi, and then if you wanted to, you can expand these out. All right, please, please, please do not forget this. It will help you tremendously. Let's look at another example. So we have sine x, we have some two terms in the denominator that are multiplied together. We are going to have to FOIL those, and our ultimate goal is to get cosecant x as a final answer. All right, so let's look at this. Sine x, we're not going to do anything with that. That's just going to stay sine x. And now in the the denominator, we're going to have to multiply those together. We just saw a problem with this, and we discovered that it could be 1 minus cosine squared x. Okay, next step, again, sine x is in the numerator. And then this, we just saw that we can replace sine squared x with it. So we have that. And then notice we have both sine x in the numerator and the denominator. So those can cancel each other out. And so I'll end up with a 1 here and a sine x here. And then because of the reciprocal identity, 1 over sine x is equal to cosecant x. All right. Here's one, a sum and difference identity. We have sine of 90 degrees minus x. So we want to go ahead and expand that out. So look at your sum and difference identities. Let's see, where are they? Sum and difference. So it's sine a minus b. So it's going to be sine a times cosine b minus cosine a times sine b. Several of my students are asking, how do we know which one of these formulas to use? Well, if it's a sine function, you're going to use this one or this one. If it's a cosine function, it'll be this one or this one. If it's a tangent function, it'll be this one or this one. And then looking at your signs, if it's plus, you're using this one. If it's minus, you're using this one, and so on all the way down, okay? All right, so we need to do, this is our A value is 90 degrees, and our B value is x. So it's going to be sine of 90 degrees times cosine of x minus cosine of 90 degrees times sine of x, okay? Now we're going to need to pull out our trig table, and hopefully you guys will have it with you on the test tomorrow. It'll help tremendously. And we know that sine of 90 degrees can be replaced with a 1. And we're not going to do anything with cosine x. That's just going to stay cosine x. Now cosine of 90 degrees is a 0. And then sine of x is just going to stay sine of x. Now notice that we went from very complicated to a little bit simpler, and then finally just our single term of cosine x. The reason why is 0 times sine x is 0, so we're not subtracting anything there, and we're just left with cosine x. Here's another example that you might see. This time you have cosine of 90 degrees plus x. So we have the cosine term here, and we want to expand it out. So we are going to go cosine of 90 degrees times cosine of x minus sine of 90 degrees times sine of x. Okay, then to simplify it, look on your trig table. Cosine of 90 degrees is 0, I believe. Yep. And then cosine x is just going to stay cosine x. Sine of 90 degrees is going to be a 1, and then times sine x. Okay. Notice here that we have a negative 1 times sine x, and we don't have to put the 1 there. 0 times cosine x is just 0. So we have a negative sine x. Right? Those are just two different versions of something that you might see. Oh, this is a fun one. Excuse me. So notice we have a double angle identity here. We have cosine 2 theta in the numerator and same thing in the denominator, but we have a 1 minus cosine 2 theta in the numerator and a 1 plus cosine 2 theta in the denominator. With this one, it will help if you look at the bottom and you notice that your goal, what you ultimately want to get, is tangent squared theta. Okay? In order to do that, you need, most likely, you're going to have a fraction with sine squared theta and cosine squared theta here. Okay? Now, if you recall, with your double angle identities of cosine, there are 3 different options to choose from. Let's see my double angle identities. Okay, so for cosine, you have, let me make this bigger. Ooh, that's a little bit blurry, sorry. There we go. So you have this formula to use, this formula to use, or this formula to use, okay? And you need to decide, okay, which one of those formulas do I want to use? Well, notice we have the doubling identity of cosine twice, but I'm going to tell you, you're not going to use the same one for both, okay? Because ultimately we want to have sine squared theta in the numerator and cosine squared theta in the denominator. Most likely you're going to want to use this formula in the numerator and this formula in the denominator. All right, so let me show you how that's going to work. So your 1 minuses are going to stay the same, and the 1 plus is going to stay the same. This one, you're doing the 1 minus 2 times sine squared theta, and then down here it's 2 cosine squared theta minus 1. Okay, well, notice the parentheses. There's a reason why we put those around there, because you have a minus sign out here. If you're going to distribute that, you end up with minus 1 and then plus 2 sine squared theta. Okay. Now, it's not as big of a deal in the denominator here, because it's just a plus sign. Nothing changes it there. None of the signs change. You can just get rid of the parentheses. Now notice here you have a 1 minus 1. Those cancel out. So in the numerator, we're left with 2 times sine squared theta. In the denominator, you have a 1 plus 2 cosine squared theta minus 1. This minus 1 cancels out this positive 1, and you're left with this. Now the 2's will cancel out, and so in the numerator, you're left with sine squared theta. In the denominator, you have cosine squared theta, which is what we were looking for down here. And then according to the quotient identity, that simplifies to tangent squared theta. I think we just have one more. Yep. Sum and difference identity with tangent. This time we have pi minus theta. So we're going to go ahead and expand the difference identity for tangent. In the numerator, we have tangent theta minus tangent alpha. I'm just going crazy. I have tangent pi minus tangent theta. Wow, going crazy here. Sorry about that, guys. And then in the denominator, we have 1 plus tangent pi times tangent theta. Okay. You can use your trig identity, your trig table, your exact value table. Tangent of theta is just 0. And then, so you have 0 minus tangent theta. In the denominator, the 1 plus is going to stay the same. And again, the tangent theta is going to be 0 times, or tangent pi is 0 times tangent theta. And then notice in the denominator, the 0 times tangent theta is just tangent pi theta, theta. Okay, 0 times tangent theta is just 0. And so in the denominator, all you have is a 1. And in the numerator, all you have is a negative tangent theta. And then, whoops, can't believe I did that. And then here we can get rid of the 1 down there. So that's gone. And then normally you would be fine with leaving it like this, but our worksheet says that they want this final answer, and really you don't have to do anything else to get that final answer just because of the even and odd. If you have the negative sign out front, it's the same thing as having it next to the x. Okay. I hope you guys do pretty good on the test. I am giving you guys 2 days to work on it, Wednesday and Thursday, and then we'll start the next unit next week. All right. Please watch the video, ask questions if you need to. Bye.